Welcome to Data Dino, where we dig into big data topics. Today, we're sinking our teeth into a giant of the data world, Apache Spark. So, here's our game plan for today. We're going to start with why Spark was even needed in the first place. Then we'll peek under the hood at its architecture. After that, we'll get into its secret sauce, lazy evaluation, and see how it gets so smart. And finally, we'll look at the entire Spark ecosystem and figure out why it's still such a huge deal. All right, let's jump right in. To really get why Spark is such a game changer, we kind of have to go back in time a bit and look at the world before Spark. What was the big problem everyone was facing?
Well, the biggest bottleneck, the real villain of the story, was the slow computer hard drive. See, the main tool everyone was using, Hadoop MapReduce, was super reliable for sure. But it was constantly having to read and write information to and from the disk for every single step. And that just slowed everything down.
And this really gets to the core of it. Hadoop MapReduce was like a librarian who, for every fact you asked for, had to run to the archives, find the book, bring it back, find the fact, and then run all the way back to return the book. Spark, on the other hand, just keeps all the most important books open on its desk. It holds the data in memory, in RAM, which is just unbelievably faster. It was a total shift in thinking. And the result of that shift? Well, look at that number. We're talking up to 100 times faster. 100. That isn't just a small improvement. That is a complete revolution. It blew the doors wide open for things like real-time analytics and the kind of complex machine learning we see everywhere today. Okay, so how in the world does Spark actually manage all this high-speed work? Well, it all boils down to its core architecture. So let's take a look under the hood at the brains and the brawn of the operation. At its heart, Spark runs on what's called a master worker model, which is actually pretty intuitive. You've got one central driver program. Think of this as the project manager, the brain of the whole operation. It figures out the master plan. And then you have the executors. These are the workers, the muscle, spread out across a bunch of machines. They're the ones actually doing the heavy lifting, running the calculations and holding on to the data. You know, the way we talk to Spark has gotten way better over time too. In the early days, it was all about these things called RDDs. They were super powerful, but honestly, you had to be a real expert to get them just right. Now, we use what are called data frames and data sets. They are so much easier to work with. It feels a lot like using a simple table. And here's the best part. They let Spark do a ton of optimization for you automatically. Okay, this next part is maybe my favorite thing about Spark. It's kind of like its secret weapon for efficiency. The idea is called lazy evaluation, and it's pretty much what it sounds like. Spark is, well, it's lazy. It won't do a single bit of work until it absolutely has to. So here's how it works. Let's say you tell Spark, hey, take this data, filter out these rows, then group it this way, and sort it. You'd think it would start working right away, right? Nope. It just sits there, listens, and builds a plan. It's creating a blueprint of all the steps you asked for, which is technically called a directed acyclic graph, or a DAG for short. It all comes down to this simple flow. Step 1. You tell Spark what you want to do. These are called transformations. Step 2. Spark doesn't do it. It just builds an optimized plan in the background. And then step 3, only when you ask for a final result like, hey, show me the data, or save this to a file, that's called an action. Only then does Spark spring into action and execute the whole super efficient plan at once. But that planning stage we just talked about, it's not just making a simple to-do list. Oh no, this is where Spark gets seriously smart. The plan you create gets handed off to this brilliant engine inside Spark called the Catalyst Optimizer. Catalyst is like having a genius engineer living inside Spark. First, it just looks at your plan to make sure it's valid, that the columns you mentioned actually exist. Then it uses a whole bunch of clever rules to make the plan better. For example, it might move a filter way earlier in the process so you're not dragging around useless data. After that, it comes up with a few different ways to actually do the job and picks the cheapest, most efficient one. And finally, it turns that best plan into super fast code that runs across all the worker machines. It's incredible. Another huge reason Spark is so popular is that it's not a one-trick pony. It's more like a Swiss Army knife for big data. It's a unified platform, which means once you learn the basics, you unlock this whole ecosystem of amazing tools. And just look at this ecosystem. You want to query data with good old SQL? You got Spark SQL. Need to process data as it's streaming in real time? There's structured streaming. How about machine learning at scale? That's MLlib. or even analyzing complex relationships with graphics. The point is, it's all right there, running on the same engine. You don't have to bolt together a bunch of different complicated systems anymore.
Oh, right, so let's wrap this up. Why are we still talking about Spark? Why is it more important today than maybe ever before? Well, it's because it basically built the foundation for how we think about modern data analytics. And this quote right here, it just hits the nail on the head. We're in the middle of this massive shift to AI, right? And what does AI need? It needs data. Tons and tons of clean, processed data. And what's the engine that does all that heavy lifting? It's Spark. It's the workhorse powering the AI revolution from behind the scenes. So if you remember just one thing, remember this. Spark's real magic was that it unified the world of big data. It combined insane speed, tools that are actually easy to use, and a whole ecosystem that can tackle pretty much anything. It made big data processing fast, powerful, and accessible to everyone. I mean, it brought together batch jobs, streaming data, and interactive queries all under one roof. Which really makes you wonder, right? What's the next great unification going to be in the world of data? A fascinating question to think about. Thanks so much for digging in with Data Dino.